I work for Comcast, which is not in Ohio. For those who need a map, because they are geographically challenged. Yep. I am from Philadelphia, which is not over here in California. Most people here are from the United States, but yeah, Philadelphia. It's 3 hours drive. It's about 2.5 hours for most of the miles, and then that last 5 miles is about 45 minutes because you're here in Virginia, DC area. It was just terrible. But if you come to Philly, there are 2 giant buildings that were built before COVID, and now they're like half empty. Well, at least mostly empty, or they're more filled now because I think there's like the mandate to go back to office. I work fully remote, so yay me. And that's because my team is in Amsterdam, not in Germany. So I wake up and they speak Dutch in the morning, and then I get on at 7:30 in the morning, and they like ignore me for a little bit, and I'm like, hey guys, how's everybody doing? They're like, oh yeah, we got to speak English for that guy. Yeah, so I work at Comcast, and I work on TV stuff. Everybody here watches TV? Okay, there's some people who don't watch TV. Audience participation, yeah, those people. But if you watch TV, and you probably watch like Netflix or HBO Max or everything, some of them actually I build, and they run inside of a web browser. How many people knew that your TV had a web browser in it? Okay, a bunch of people, that's good. And one of those web browsers is WPE. It stands for WebKit Embedded, which is a really optimized version of Safari that's made to run on really, really slow hardware. And if you've had a TV for more than a couple years, you'll also know that they don't update the browser on those TVs, which is like really painful. So I remember I've been a web developer for a really long time, 20 some years. I remember the days of IE6, and I remember the days of having cake and ice cream when IE6 was retired. It was the best day ever. But then there was 7 and 8, and eventually they went away, and now we live in a world where if you're a web developer, you get a new version every
6 weeks.
6 weeks, thank you. Thank you. Yeah, they get pretty often. But in TV years, you don't get new browsers. And I still have to support Chrome 38, which is before Fetch was added to Chrome. So it's pretty old. It kind of stinks. But the benefit of developing with a web browser on the TV is I actually get to develop on my laptop. And what I do on my laptop in the Chrome browser actually looks pretty good on a TV device. But there's more challenges for developing on TV devices because it gets harder, right? Life gets harder. Anybody use a Raspberry Pi or like Raspberry Pis? They're awesome, aren't they? There's like a Raspberry Pi 5 now coming out. But this is the specs on a Raspberry Pi 4, which came out in 2019. It's got gigabit. It's got about up to 4 gigs, 8 gigs of RAM. It's got a pretty nice processor. But if you compare a Raspberry Pi 4 to your MacBook Pro, which this is like MacBook Pro from 2012 is how I compared it. A MacBook Pro is 500% faster than a Raspberry Pi 4. Okay? So it's way faster. And then if you compare that to like an Intel processor, like you get 4 cores, 8 threads versus 1 processor with 4 cores on it. Some of the TVs I work on don't even have multiple cores. They have 1 processor on it. So you can't do like multi-threading on it. And just to get some more comparison, your iPhone 14 is 800% faster than a Raspberry Pi 4. So your phone is infinitely more powerful than your TV device. And if that wasn't bad enough, you know, when I was doing this research, I was comparing the Raspberry Pi 4 to an iPhone, and I talked to my boss, and I'm like, yeah, I'm trying to get numbers to be like, explain this to people in the audience of how fast or how slow their TV device is. And he's like, well, it's really closer to a Pi 3 than a Pi 4. So I was like, oh man, I created all these slides already.
Does anyone really need convincing that Xfinity X1 is slow?
Oh, X1 is like the app stuff. But this is for TV devices. But yeah, that was like the XRE system. And the hardware in those devices is really slow. But yes, thank you for backing me up on how slow these devices are. So just to throw it in further, the Raspberry Pi 3 is about 34% slower than a Raspberry Pi 4. So these devices are basically turtles. They're turtles. They run really slow. And the issue is that if you try to build a website on these devices, and this was our first attempt. We built this screen with HTML and CSS. HTML and CSS is really great. Like, it's really great for layout and everything, but it's really complicated. For those who don't know, there's rendering that has to happen, which is basically your browser taking all the DOM markup that you made, converting it to a DOM tree. They do the same thing with your CSS. They convert that to an object tree. Then they have to mash it together. Then they have to do all kinds of calculations to figure out how big are your divs? How tall are they? What's the layout of them? How do they flow with other divs and everything? So they do all this computation, and then they have to render it on the screen, which is a really, really computationally intensive process. That's kind of slow. And if you want to find out more about that, Chrome Developers has a great website that is like 6 pages of reading all about how browsers render. It's a really complicated process. I read through all of it. I understood, 20, 30% of it, and I skipped over the graphics stuff because that gets way too intense. Don't read that stuff. But it's really complicated. So in order to work around this, there is this framework called LightningJS, which I am part of that team. Surprise, surprise. I have a shirt that says LightningJS is faster than you can React. It's a play on React. Humor. Thank you. Someone laughs. I have jokes all day. But LightningJS is written in webgl, which is a canvas tag. Ta-da! Who knew about canvas tags that exist in browsers? Like, I've been a web developer for a really long time. I avoid canvas tags because they're like, nobody wants to work in that. Nathan is talking later today about like SVGs and canvas tag, and he does drawing and stuff. And I'm like, oh, those people who do canvas tag stuff, that's like drawing APIs. But the reason why you'd want to use a canvas tag is because canvas rendering is way faster than rendering HTML and CSS. And when you're dealing with turtles, you really need to like edge out all the performance you can, which is where webgl comes in. So we have built all kinds of UIs, and we're basically all of your UIs on TV boxes look like this. You have some kind of browse screen that lists all these little poster arts, and you need to display it. And we had a framework, Lightning 2, which a lot of developers actually use. A lot more people in Europe use it. And Lightning 2 has been out for like 3 or 4 years. It was a monolith framework. Everybody loves monoliths, right? There was no reactivity in that. And web developers, you're probably like, what's reactivity? I think, don't we all take that for granted? That's where you change a variable and the UI automatically updates. And you're like, of course it does. Like, every framework does that. Well, Lightning 2 did not do that, okay? If you wanted to change the UI, you had to call patch, and you had to send it what the new variable change was, and you had to tell it where it needed to change and everything. It was a pain in the butt. It was a unique framework. Go out on whatever that higher thing website was that we just learned about this morning. I'm drawing a blank. Golands. And be like, I need to hire a Lightning developer. Nobody's heard of it. Nobody's heard of it. Because it's very unique. There's probably 5 or 10 cable providers out there who need to do their own UIs and stuff. And the other thing is it's for Chrome less than 38. So really, really cool JavaScript code in there. So the team has been developing Lightning 3, which is in beta right now. Go try it out. It's awesome. And we've been developing this new one. And the first thing that we did was we separated out the renderer process from the actual framework. And the renderer is the thing that's responsible for doing all the draw commands. So in the renderer code base, we have this cool little thing, which is this like gecko thing animating and going through, and an elevator animates up and down. And in order for this to work, you go in and you write code like this. You tell the renderer, I want to create a node, which is an image. You tell it what's the XY position, how big is it, where do you want it on the screen, what color do you want it. And in the same way, you can create text nodes, which is just like hello world. And you can tell it what XY position on the screen do you want it. And the renderer will do that for you. The renderer will also animate things on the screen. Yeah, and you're like, this is great. And that's all the renderer does. It takes nodes and it takes text nodes and draws them on the screen. But we want to build something really nice, right? Like, we want to build this beautiful screen for our customers to see. We obviously don't want to write all these little create nodes and create text nodes. This is where we need a framework, right? We all want to use a framework. I think anybody who does web development today, probably few people actually know how to do HTML and CSS without a framework. I mean, yeah, I'm old enough. I know how to do. I can write divs without React. Yeah, I know how to do reactivity. So we built our own framework because that's what you do, right? You need a framework to work on top of this renderer. The team created Blitz. They had to come up with this code word. It used to be called Bolt. They had to create a logo for it. And they have like this marketing thing of like it's easy XML. It's built in reactivity, clearly defined, blah, blah, blah. All the selling points for this framework. And I was like, ugh, YAFS. That's what I said. I said YAFS. For those who haven't heard of this acronym, it is yet another framework syndrome. Yes. Everybody who's a front-end developer definitely understands this, right? And this is where we segue into Seinfeld. So let's see if I go over here. Unfortunately, there's no audio, but in the back of your mind, just you know how they sound. So we're going to play this. Hopefully, people can see this pretty well. Yeah, and this is like so true. I love that little thing. Let's go back. Where are the slides now? Wait, this is the slides. There we go. Okay, I'm back. And this is the big joke in front end, right? Like, oh, there's a new front end framework every week. And now it's like there's a new database thing that you're using every week. Ha, back end developers. Jokes for them. But yeah, this is what it's like in front end space. And I'm like, oh man, people don't understand. Frameworks are like having a baby. Dude, like, of course, it's fun. It's fun to create a baby. I mean, that's fun. But then, it's fun for the 9 months that you're waiting for the baby to come, and you're like, this is great, it's going well. But once that baby comes out, you're like, oh man, I gotta support this thing. I'm up in the middle of the night, it's crying, it's whining, I don't know what it needs food, I gotta feed it, I gotta, just get away from me. You want the thing to go away, and you can't get rid of it. Once you release a framework and people are using it, you support it forever, for years, and it doesn't go away. Why would you want to have a baby? Don't have a baby. You need to realize, like, the initial work for having a baby is nothing. After you develop something, maintenance accounts for 60% of software development costs. At least. Yeah, all the costs are in the future. I mean, college, it's so expensive. Kids need so much clothes, they outgrow them. You buy them shoes, the next week they need new shoes. What are they doing? Stop growing. Making a baby is so much work too. You have to write it. You have to write it from scratch. Like that's the fun part. You like the ingenuity, you like to have things. Then you need tools for it. Maybe you can use Vite, maybe you can use some open source stuff, but then you need plugins to go with VS Code because your framework is slightly unique. Then you got to write all your own documentation. And of course you need a router. Every framework needs a router. Then you need a playground so people can use it online. You need examples. Teach people how to use your new framework. This is so much work. Why would someone want to do this? So really you need to say, well, how do I get a framework without having to make my own framework? And this is where I say BYOF, borrow someone else's kid. Why make your own kid when you can borrow a kid from your brother? And just take him out for the day, have fun, and give him back. You're tired of him, right? Man, yeah, this is where SolidJS comes in. Bring your own framework. Ryan Carniato, he is the founder of SolidJS, the author behind it, and he wrote a JavaScript framework in 2018. And we're going to get into this. But he's awesome. I love engineers like him, not like myself. I'm like a wild cowboy coder. I just make things happen, blow things up, and then run away. But he's one of those engineers who's very thoughtful, writes down what he's doing, why he did it. Like, I don't write down anything. Writing is for really smart people. So he's really smart, high IQ. He's someone who gets the job. And I love that he's like, he didn't set out to create a framework. This is like, nobody sets out to create a baby. It just happens, right? Yeah, but he acknowledges that in 2018, it isn't necessarily new at all. He borrowed ideas from all kinds of other frameworks, especially React. React has won the framework wars in front end. Like, they are the most popular thing, and they do one thing really well. They render. They create UI. And the cool thing about React is they've created a huge ecosystem. And the ecosystem is actually probably one of the most important things about a framework. Full-fledged, lots of people using it. You can get help and support. So why SolidJS? Why do we need another JavaScript UI library? And I love this, right? He's an engineer who had to write an article to defend why he made a baby. And his summary is, so I just did it, right? You know what? He doesn't need validation from anybody else. He just made the baby. And he has reasons for why he made the baby. And it's a great article. You can go through and read all the reasons. But to summarize why, he has another article introducing the SolidJS framework. Again, right? Like, I love this engineer. He writes lots of articles summarizing his thought process and why he did certain things. Number one, SolidJS is the fastest front-end framework that exists. For me, who works with turtles, instantly got my attention. SolidJS, the fastest. I need that. Speed is very important to me. And there's benchmarks that compare SolidJS to all the other frameworks. Yes, it is faster than Svelte, whoever came up with that name, the disappearing framework. Yep. It's also the smallest. Really great. Everyone knows that the more JavaScript you load, the longer it takes. Less JavaScript, faster. Win-win. And then they summarize the bundle side compared to all the other frameworks out there. The other thing that's really great about SolidJS is it's fully featured. That means all the things, like everybody's probably knows React or Angular or Vue, like those are the kitchen sinks, right? You get everything. You get so much stuff. SolidJS gives you all those things too. Fragments, portals, context, suspense, error boundaries. I don't even know what half these things are. They sound pretty cool. They're cool names. Async and concurrent rendering, implicit event delegation. Yeah, I mean, you get all those things, right? Everything that you're used to if you're coming from React. And I like that he didn't reinvent the wheel. It's familiar. Like our Blitz templating system is a brand new templating system, and nobody's used it before. So then you have to spend the time learning something new. Who wants to do that? Use something that already works. We know that JSX works really well. Just reuse it. Some people don't like it. I'm like, okay, fine. You can go with like Vue.js. That's fine. You don't have to use JSX. With Solid, you kind of do. So, but I like it. You get used to it. The first time I saw JSX, I was like, how is this working? This isn't valid JavaScript. Where are the strings? Like, oh, it's compiling. It's got to compile down to do something. But it's familiar. It's established. This is another key feature, right? 29,000 people have already started this and are liking it. If you try to hire someone for a framework that you wrote, there's no one available. No one has heard of it. You won't hire anybody for it. Your team will be proprietary. Good luck finding new people to work on a framework that nobody else knows. So what are some cool things that he introduced with SolidJS? One of the most important things are signals. Anybody heard of signals? This is now like a big feature in Angular. And I'll read this real quick. Signals are the cornerstone of reactivity in Solid. They contain values that change over time. When you change a signal's value, it automatically updates anything that uses it. This is such an important concept that Angular actually like integrated signals into their framework as well. And this article is so cool. Everyone is talking about signals, right? Like, you guys probably just hang out like, hey, have you heard about those signals? Like, signals are awesome, right? Are you using them yet? Yeah, they're so cool. Make sure you talk about them during lunch too, just like that too. Hey, other people over that other talk, did you hear about signals? I hear they're the cool thing. But yeah, they are pretty cool. How do they work? What is this? So if you're familiar with like the pub sub type type APIs where you just subscribe to thing and you're a listener. This basically does it automatically. So you get a variable back. So here we have a count, which you do create signal, very similar to like create state in React. And it returns a variable, but in order to access that variable, you call it as a function. And as soon as you access it, you're inside of a tracking scope inside of SolidJS that automatically subscribes you so that when setCount is called, it automatically knows to notify you. It's like magic pub sub. Such a novel, simple idea that's like really cool. It's really powerful because then every template that you make, everywhere you use signals, which the whole framework is signals, it just automatically updates. And it automatically knows where to update. That's why it's so performant. Okay. So effects are the other thing that go with signals. You can actually listen for signals to change. And then you'll notified, so inside of here, it's a create effect. Anytime count changes, since you're reading count inside of that function, it will automatically call this function every time count changes. It's like, wow. I had to spend time like reading the framework to understand how that worked, to know about pub sub and tracking systems inside of there. But it's really clean, it's very simple, and it's a really good novel idea that I like. All right, so the other great thing about Solid is it has tutorials. Like using someone else's framework, you get tutorials, you get APIs, you get all this stuff that already exists that you don't have to build for yourself. If you are a React developer, there are already blogs and articles about the things that you need to know jumping into Solid. How is it slightly different than React? There are cheat sheets available that you can go to and you can hover over all this API. This is the entire API for SolidJS. It's not that bad. It's pretty small. It's like 7 kilobytes of code. You can hover over it, get all kinds of information about it. It's also TypeScript, so you can be in your editor and get information. TypeScript can complain at you all the time about, why aren't you doing it the right way? This is not that type of node. And there's also demo apps that they've built. So this is like the Solid Movies app. That's what I do. It's written in HTML. This thing is super fast loading it up. And it's all server-side rendered. It's crazy awesome. They have a wonderful playground that works, that you can go and write some code in and see it working. So what about Lightning, right? Like, wow, I just went off on a tangent there about SolidJS, because SolidJS is really awesome. Highly recommend it for web development. But this is where Ryan created this universal render target. So he has this huge PR, lots of documentation there. Love this guy. And summarizing this, he says components in Solid are just functions. If you never use a native element, lowercase, like div or h1, and don't call render, we never need to import DOM APIs. You can build whole systems with Solid just using components and the reactive system. Like here is Solid rendering WebGL. I was like, I need to render WebGL. Man, this guy's just like, he's so nice. But he built this whole thing in a universal renderer for me. And I want to like emphasize, and this is what he also emphasizes, like all ideas grow out of other ideas. There's nothing novel here, right? React Native has been doing this for years, or Flutter. They have this concept of building for multiple platforms. And how it works if you're building for Android and iOS is you write the React Native UI component, which is this first column here. You write a view, you write a text, you write image, you use these very simple primitives. And then when the compiler runs, it goes through the build process and says, oh, are you targeting Android, you're targeting iOS, you're targeting both, and it builds it and it replaces those primitives with the native ones. I'm like, wow, how simple of a concept. I mean, it's really tedious. I would never want to write that program because it's like, wow, there's so many. I actually looked at using React Native as the first like universal renderer, and I'm like, they have 40 or 50 components that I need to implement to do that. And I was like, wow, this is hard. I don't like things that are hard. So I got SolidJS working with Lightning, and here it is in the playground. There's a canvas, there's a text, but it's doing the same stuff. And in order to implement this, SolidJS gives us these functions. So this is the bridge between Lightning Renderer and SolidJS. I just had to implement these functions to do something with the Lightning Renderer. And if you notice, it's create element, create text node, insert node, like node. If anybody of you are computer science people, you probably heard like we're building a DOM tree. This is essentially a DOM tree. You have parents, you have children. Everything is about parents and children in life. Everything. children, you just can't get away from them. Once you have them, it's like, oh, you got to go public speaking and travel. Anyway, but let's look at how this works, right? So here's hello world. We have canvas, we have view, we have text. And the cool part about this playground is you can look at the output of what's happening. So when this compiles down, it goes create components, and then it has the name of the component view, and it has some props in there, the color. And we can break this down further. So rather than using view and text, which are my high-level primitives, I can use the lowercase node and text. And those are not being changed at all from the framework. And so now it's just calling create element and set props on that element. And this is, again, those functions that I had to implement. So all now I have to do is tell it when you get a create element, call the renderer create node, and pass those same props to the renderer. And it will draw all my little things on the screen. And when I get create text node, I tell it create a text node in the renderer. And I manage that little DOM tree. And from there, we now have this system where we can build really cool UIs. And all it's doing is changing all those views and text to create nodes, create text nodes, and managing the relationship. And text rendering I want to talk about for a few minutes because it's really fun. So in order to do a layout like that looks really simple. And you're like, of course, this is HTML and divs. We've been doing this for years. But text is really hard, really hard. There's so many different types of text. There's right to left text, Arabic text, Japanese text, I think, or there's all different ones. And I looked up text rendering, and there's this cool website, Fault Lure, and text rendering hates you. I was like, yeah, this is the article for me. I want to read this. Rendering text, how hard could it be? As it turns out, it's incredibly hard. Luckily, on our team, we have Frank. So this is Frank. He's on the Lightning team. He wrote an SDF renderer, signed distance field renderer. Rendering text is really hard, but he renders it, and then he returns back, this is the width and height that I calculated for how big hello world is. And from there, I get a width and height back because you have no idea how big hello world is because it's like, what font size is it? Well, what text are you rendering it? It could be different. It could be different all over the place. So I get that information back. I wrote a really simple I'm near the end of the talk. So flexbox algorithm, really cool. Not that smart of an algorithm because I'm not that intelligent. But I wrote a really simple one, and that allows me to do text rendering. I get the information back about how big is this text, what's the width and height, and then I can do layout using a simple flex algorithm to move things around. So you actually have to tell the renderer, render me hello world. It will return back, okay, it's this big, and then you do layout. So layout is actually really complicated. But I added a few of these little simple primitives in here to make it a lot easier than what we did with Lightning 2. Lightning 2 was a nightmare working with text. You had to do all this manually. But now I have little helpers like padding so that I get the width and height back of the text, and then I can draw a circle around it. You're like, wow, I can do that with HTML and CSS really easily. Yes, but do you know how long it takes the browser to calculate that? I mean, it's a fraction of a millisecond, but if you're moving at turtle speed, it's one whole millisecond. It's slow. It is really slow. But from here, with all these little helpers, we can build really cool UIs like this. So this is the sample app that I built with SolidJS and Lightning 3. It's open source. You're welcome to check it out. It's cool. You navigate everything with keyboard because when you're using a TV, you use a remote control. And the great part about this is I am using all of SolidJS APIs. So this is the actual code snippet. I have my view, I have my text in there, tile rows, I'm creating components. But everything that I'm using is all the SolidJS API. I get to reuse everything that they're using for web that 30,000 people are using. I know that it works. I know that it's great. I know that it's going to constantly improve, and my stuff can take advantage of it. I get to use all the cool JSX control flows that they offer, like show and for loops, to loop through arrays and create stuff. So in summary, don't make your own baby. It's better just to use other people's babies. You can find them at nurseries. If you volunteer at churches and you get to watch kids, that's the best way to play with kids. You only have to deal with them for an hour, and then their parents will come pick them up. It's the best ever, okay? If you don't like SolidJS and you hate JSX syntax, well, Vue.js also has a custom renderer API. And it's the same API as like the SolidJS one, so I could easily tie this into Vue.js, which I plan on doing at some point. All right, we are at exactly 30 minutes.